All right, guys, let's go ahead and finish up this FRQ from today. This is FRQ Part B, number 1. Let's start with Part A. They give us a piecewise function, and apparently this piecewise function represents the depth of a river at certain points, and T is measured in hours. So I guess over time the depth of the river changes apparently. So Part A is asking us to find W prime of 8. And then using the correct units, explain the meaning. All right, so we need to find this, we need to do this, and we also need to explain the meaning. That's 3 things they're going to be looking for on this one. So first of all, let's find W prime of 8. Well, first of all, notice the T value that they give us, it's 8. That means we're on the time interval from 6 to 10, which means that we're going to be using this piece. So for that time interval, W of t is equal to 10 minus 1/5 t minus 6 squared. And therefore, W prime of t will be, let's see, the 10 goes away because it's a constant. Then for this piece here, we're going to do a chain rule. We're going to multiply the 2 times the negative 1/5, and that gives me negative 2/5. And then we multiply it by the derivative of the inside, but that's just 1, so we don't really need to worry about that. So there's my derivative, and now we're ready to plug in 8. You could simplify it if you want to. If you do that, you should end up with negative 4/5, but you could also leave it like this because we're doing an FRQ. All right. Now they want us to give the correct units. Now, W is measured in feet. So W prime must be in feet per hour. Now, that's the units, so we've got that checked off, we've got that checked off, but we still need to explain the meaning of this. When you do an explanation, you need 3 things. You need input units. In other words, whatever you plugged in. I plugged in 8, so that's a time. In hours. You need your output units. In other words, what are the units of your answer? That's feet per hour. And then you need the context. In other words, you need to actually explain what this stuff is in the story problem they're giving us. And so what a proper explanation of this means would be the following. At t equals 8 hours, the rate at which the depth is changing is negative 4/5 of a foot per hour. So in other words, the river's getting deeper, well, actually less deep apparently, at a rate of 4/5 of a foot per hour. Now, why do I say less deep? Because it's negative. Another way you guys could have said this is you could have said at t equals 8 hours, the depth of the river is decreasing at a rate of 4/5 feet per hour. Okay? Let's go ahead and move on to Part B. All right, the graph of W is concave down on this interval here that they're giving us. Use the line tangent to the graph of W at t equals 3 to show that W of 3.5 is less than or equal to 9. All right, so here's what comes into my mind when I see this. They're telling me my graph is concave down, and we're talking about a tangent line. Now, they want me to also show that the value of my function is less than 9. So here's what I'm going to do. If I can prove that my tangent line is less than 9, then that means that the function has to be less than 9 because the function is underneath of the tangent line when it's concave down. So I'm going to say all that again. If I can prove that my tangent line is less than 9, then that means that the function has to be less than 9 because the tangent line is greater than the function And I know that because it's concave down. So let's start by finding that tangent line, which, as you guys know, is x, y, and m. And we want the tangent line at t equals 3. So I need to find my y value. Now, they didn't tell me my y value this time. Some of you might be thinking it's 9, but it's not. That's not the y value that goes with 3. That's the y value that they want me to show is greater than everything else. So I need to find the y value at 3. Now, since I'm at 3, I'm going to be using this interval and therefore this piece here. So w of 3 is equal to 17 over 2 minus 3 over 2 cosine of pi times t, which apparently is going to be 3, over 6. Now, 3 over 6 reduces to pi over 2. And this is where trigonometry can come in handy, because this is not a calculator-based test or question, and therefore we can't really use our calculator. We have to actually be able to figure this one out. Now, since it's an FRQ, you might think, well, can't I just leave it like this, Mr. Bailey? Well, technically, yes, you could. The problem is that eventually, somewhere down the road, we're going to need to show that something's less than 9. And if you leave it like this, you're going to have no idea what that equals. So we actually do need to simplify this. So cosine of pi over 2 just so happens to be a nice number. It's 0. 3 over 2 times 0 is nothing. And so my answer is 17 over 2. Matter of fact, I think I'll just change that into a decimal. 17 divided by 2 is, what is that? 8.5. There we go. All right, now let's do the slope. Now to find your slope, we need to find w prime of 3. Well, to find w prime of 3, first of all, let's find w prime. Once again, since we're at t equals 3, we're using the top function. So what would the derivative of the top function be? Well, if I take the derivative of 17 over 2, I get 0. So this just goes away. The constant multiple is going to stay there. The derivative of cosine is negative sine. And then the derivative of the inside is pi over 6. Okay, so I had to do a chain rule there. All right, so that's what I'm going to do to find my slope, and I want to plug in 3 now. Now, if I plug in 3 here, it's going to be 3 over 6, which is 1 over 2. So I'm just going to simplify it now and call it pi over 2. Now, sine of pi over 2 just so happens to be a nice number. It's 1. So I've got negative 3 over 2 times negative 1 times pi over 6. Putting all that together, I'm going to end up with, I'll put it over here actually, positive 3 pi over 12, which reduces to pi over 4. So there's my slope. Now I've got my tangent line. Now what do I do? Let's write the tangent line. Y equals pi over 4 times x minus 3 plus 8.5. Now let's go back to the original question, because we've done a big task there and we don't want to lose sight of where we were. So we're talking about this graph of w, which apparently is concave down, which means that the tangent line is above that. So if I can prove that my tangent line is less than 9, then that would mean that my function has to be less than 9, because the tangent line is bigger than the function. All right, so I'm going to plug in 3.5 to my tangent line and see what I get. Now this is a non-calculator based question, and so we've got a pi in there, and so we're just going to have to do our best with rounding things here. First of all, that's 0.5. 3.5 minus 3 is 0.5. Next, we have 0.5 times pi over 4 is pi over 8. Now you might think, well, why is that, Mr. Bailey? Well, think of it as 1 over 2. If it's 1 over 2, then 1 over 2 times pi over 4 is pi over 8. And golly, that's not a very pretty number, is it? Pi divided by 8. So I guess what I would do at this point is I would just change that into a decimal. I would divide the top, which is about 3.14 by 8. That's going to be 324. 8 goes into 72 about 9 times. So I'm gonna round this to about 0.4. And that's 8.9. All right? So there's my answer. Now, I want to prove this, right? Well, here's what I know. I know that y of 3.5 is equal to 8.9. And I know that since the function is concave down, the tangent line has to be bigger than the actual function's value at that point. Now, 8.9 is less than 9. So, since my tangent line is less than 9, and it's also greater than the function, that means the function must be less than 9. All done. Okay? So that was kind of a tricky one. A lot going on there. Let's go ahead and move on to part C. I think I say they're all tricky at this point. These questions are pretty tough. If you're feeling kind of overwhelmed, you're not alone. These are tough. But that's what this time's all about, is just letting you guys see all the different types of questions there are. Let's take a look at part C. So with a limit, this is kind of a flashback to last week. When you do a limit, the first thing you always do is you always try your direct substitution first. So let's try direct substitution. We're just going to plug the 2 in. All right, let's find W of 2. So if t equals 2, I'm on this interval, and therefore I'm using this piece. And I'm going to be plugging in 2 for the t. Now, if I plug in 2 here, that's going to simplify to pi over 3. And cosine of pi over 3 is a half. So I have 17 over 2 minus 3 over 2 times a half, which is 17 over 2 times 3/4. And if I get a common denominator here, I get 34 over 4 minus 3 over 4, which is 31 over 4. And man, it's so frustrating. It's like if they don't want you to use a calculator, it'd sure be nice if they would just let things work out with numbers that aren't a pain in the butt. But I guess they just don't care about that. All right, so W of 2 is 31 over 4. I wonder, yeah, I'll just leave it as that. I'll just leave it as a fraction. 31 over 4. Now, 2 to the third power is 8. Now I need to combine all these together, so I'm going to think of that as over 1. I'm going to multiply the top and the bottom here by 4, and so that becomes 32 over 4. So let me replace that then with 32 over 4. And just kind of like what I was expecting there, notice that the bottom of this whole thing equals 0. Well, if you combine all these, you also get 0. And when that happens, you're going to be using L'Hopital. So L'Hopital it is. All right, so this limit then, now on an FRQ, just so you guys know, if you see something like this, you would say this yields the indeterminate form 0 over 0. Therefore, the limit as x approaches 2, now we're going to do the same thing but with the derivative. So it'll be w prime of t minus 3t squared. The 1/4 goes away, and the bottom is just 1. And now we're going to do direct substitution again, but this time with the derivative there. So we need to find w prime of 2. So we need to find the derivative of the top and plug stuff in. So the derivative of the top is going, that goes away. You're left with a negative 3 over 2. The derivative of cosine is negative sine. And we're plugging in a 2, which would make that become pi over 3. And that's that. Oh, the derivative of the inside is pi over 6. I should have put that there too. So there's our derivative after we've plugged in 2, and we'll go ahead and simplify it. I think at this point, gosh, I think we could just probably leave it, but I'll go ahead and simplify it. But you guys could literally just take this, I think, at this point and put it here, and then simplify that and be done. But I'll go ahead and just simplify it because I feel like it. All right, sine of pi over 3 is radical 3 over 2. All right, and if I put all these together, I get 3 radical 3 pi over 24. And then these reduce. This is all kind of silly work, honestly, at this point, because you don't have to simplify it. And then this is 12. And I would definitely stop there. I think that's good enough. But there you have it. So there's our limit. So basically, the big thing here is L'Hopital. That's what they want you to get. And just so you guys know, it's going to be tempting for you to say that this equals 0 over 0, but don't do that. Because 0 over 0 is not a number, so you can't say it equals 0. And if you do that, they will actually take a point off. What we do is we say it yields the indeterminate form 0 over 0, and then you write the derivative. Okay? So there's that. Let's go ahead and move on to the next FRQ. Once again, no calculator. Maybe they'll give us reasonable things this time. All right. A particle moves along the x-axis so that its position at any given time is this. So they're giving me a position function. Let's take a look at question A. Show that the velocity of the particle at time t is given by this here. So, as you guys know, velocity is found by doing the derivative of your position function. And the derivative of my position function is going to require me to use the quotient rule. So let's do the quotient rule. So after I do the quotient rule on this, I should end up with that. That's my goal. So we do low. I'll write this out again. We do low d high minus high d low. We draw a line. We square below. So, as you can see, my bottom looks good. They match. This matches this, but the tops don't match yet, right? So we need to simplify this up here in order to get this to work. So let's go ahead and start with some distribution. That gives me 6t cubed plus 16t. Distribute this and the negative. You get minus 6t squared plus 54t, I believe. All right. I'm sorry, this is supposed to be a cube here, actually. All right. Let me keep the bottom the same. All right. The t cubes go away. the 16t and the 54t become 70t. And now we have what they wanted us to find. There's that. That's the end of question 1 there. Let's go ahead and take a look at question number 2. Or question B, I should say. All right. Is the particle moving toward the origin or away from the origin at t equals 2? So in order to find out whether it's moving toward or away from the origin, I need to know 2 things. I need to know where it's located, and I need to know what direction it's moving. Okay? So, for instance, let's say that this is the origin, and let's say that my particle is somewhere over here. So if my particle is to the right of the origin and it's moving left, then yes, it's moving towards the origin. But let's say that my particle is located to the left of the origin and it's moving left. Well, now it's moving away. So as you guys can see, you need to know 2 things to know whether or not it's moving toward or away from the origin. You need to know where it's located and which way is it going. So the position can be found by using the position function that they gave us. Direction comes from velocity, which, as you guys know now, is the derivative of the position, right? Now, they want to know what these things are at t equals 2. So I need to find x of 2, and I need to find the velocity at 2. So I'm going to plug in 2 for these. Right? So let's get down to business. X of 2 is equal to 4 minus 9 is negative 5. 12 plus 8 is 20, which is negative 1/4. So my particle is located to the left of the origin. All right, so if my origin is here, my particle is to the left of it. So now I need to figure out which way the particle is moving, and for that we're going to use the derivative, right? So that's this formula here that they gave us earlier. That ends up being 140 over 12, and I don't really need to reduce it because it's positive, and that's all that I really care about. So my object is moving to the right. Okay, and so since my particle is located to the left of the origin and it's moving to the right, is it moving towards the origin or away from the origin? As you guys can see, it's moving towards. So now really what I have up here is enough. I've already explained what this is. I've explained what this is. So now I'm ready to put my answer. It's moving towards the origin. But if you wanted to be a little bit more formal in how you write your answer, you could write it like this. Since x of 2 equals negative 1/4, and x prime of 2 is equal to 140 over 12, the particle is to the left of the origin and moving right. Therefore, it's moving towards the origin. All right. Let's go ahead and move on to part C. The acceleration of the particle is given by A. Now, as you guys know, acceleration is equal to the derivative of velocity, which means that that is going to be the second derivative of the position function. So they want us to find a of t. In other words, we want to find the second derivative of the position, or you could just take the first derivative of velocity, and then they want us to plug in 2. So let's do that. So my velocity, as you guys know, is this. So v prime of t would give me my acceleration, and therefore we're going to do the quotient rule again. So we have low d high minus high d low. Now the d low is going to require a little bit of work here because it's going to require a chain rule. So we have the outside, which is the square function, and then we have the inside, which is the 3t squared. So the derivative of the outside will be 2. And then the derivative of the inside will be 6t. So there's my low d high minus high d low. Now we draw a line and square below. So it was already being squared, so if we square it again, you're going to get 4. But I'll just write it like that for now. So I would just stop there. I wouldn't try to simplify it. If they wanted me to do something else with the acceleration, maybe I would simplify it. But in this case, all they really want me to do now is plug in 2. And so I'm just going to plug in 2, I think. It'll be easier than simplifying it. So they would probably give you 1 or 2 points for doing the derivative correctly there. Now let's go ahead and plug in the 2 and see what we get. So if I plug in 2 here, I would get 20. If I plug in 2 here, I would get 140. If I were to plug in 2 here, I would get 20 again. And if I were to plug in 2 here, I would get 12. On the bottom, if I were to plug in 2 here, I would get 20. And I'm not even going to simplify that because I don't have to. That's all we need to do. That's the other point, is just plugging it in. Okay? All right. Let's go ahead and move on to our last question for the day, part D. What position does the particle approach as t approaches infinity? So you guys see this word approach? That means we're talking about limits. And what we're approaching is, well, it's not x, my bad, it's t. We're talking about as t is approaching infinity. So what are we taking the limit of? Position. So I'm going to put my position function here. Now if you were to do direct substitution, here, if you put infinity in here, you get infinity minus 9, which is infinity. And if you plug in infinity here, you get 3 times infinity plus 8, which is infinity. So we'll say this yields, I think I misspelled yields there. I don't know. This is math, not English, so I'm going to say, who cares? All right, but anyway, it yields infinity over infinity. Therefore, by L'Hopital, we're going to say that the limit, therefore, is equal to the following. Take the derivative of the top and the bottom. So I get 2t over 6t, and these reduce, which means that I have the limit as x approaches infinity for 2 over 6, which is 1/3. And anytime you have a constant there, that means it's always 1/3. Doesn't matter how far out to infinity you go, it's always 1/3. And so there's our answer. So what position does the particle approach as t approaches infinity? It approaches a position of 1/3 on the x-axis. All right, so it's a L'Hopital question. All right, and that'll do it for today. So hopefully that was helpful. We'll see you guys tomorrow. Have a good one.